you all are aware that architectural discipline, which is there, is not insulated from technology. In fact, it is more technological driven. Whether you see which is happening in the process of designing, or whether you see which is happening in the process of making products, that is a final finished product. So everywhere, wherever we go, in our architectural discipline, technology makes a very prominent role. Remember in olden days, they started with basically post and lintel construction. Then the advancement happened. They started inventing the keystone, and then the arch was formed, and then a dome was made. Suddenly, when the dome was made, you had walls which was very thick. Suddenly, the techniques and technology changes. You started having those flying buttresses, thin walls with high roofs. Then suddenly, with the Industrial Revolution, you had your steel coming into the picture, and you start having your buildings which is made up of steel. Then with the technology, further advancement happening, concrete coming in. So what I mean to say is, whatever buildings we design, whatever we teach to our students, we cannot be insulated from the advancement which is happening in all around us in technology. With this as a background, and Sone Pe Suhaga on top of it, there's something known as outcome-based education. Now, when this topic was given to me, I thought, why not go deeper into it and understand what is outcome-based education? So I thought I'll start my journey with first understanding as to what is outcome and what are the terminologies which is involved in outcome-based education. And what is a tree which is there for our outcome? All this thing you may have covered in the previous sessions also, but I'll just briefly touch upon it and just to recapitulate as to what you have understood up till now. Then we are talking about making our architects which are future ready. That means we are teaching to them in our architectural colleges and institutes whether they have the skill set which is required 10 to 20 years hence. Like remember, once we were having our own education, that time we used to teach, basically we used to learn and make our drawings by hand drawing, then sketches. Slowly with the advent of ink, rotary pens and other things coming in, we started making the ink. Then we suddenly switched on computer coming in, the computers were coming in. We thought first we used to make perspectives. Now we make modelings and other things. So all these things, now what we expect once our architects are made after 5 years down the line or 10 years down the line, what are the skill set is going to have is what I've just listed in that. Then I thought, what are the 3 pillars which are required for the future of architecture? I'll be talking about that. I did some study on that. Then I collated everything and made one pentagon. So that pentagon is the change which is going to happen and which we all going to remember and have to work towards it. And then we'll just see with examples what are the emerging technologies and techniques which is happening. And in the end, for our architectural curriculum, I've just suggested one model. So this is how my whole brief is going to be there for today's lecture. First, as to what is the outcome? What do you mean by outcome? So outcome of education is what the student should be able to learn at the end of the program of course. That means the focus now is shifting. Previously, it used to be what more of a teacher-centric. They used to come, they used to teach something, and the learning used to happen. But now, slowly, the thing is switching towards the student learning. This is what is also being propagated by your new education policy also, as to we have to move towards outcome-based education. We have to know as to what the student is going to learn after he exits the program. That means all our curriculum has to be driven by the exit learnings of outcomes. And whatever outcomes we are able to make, he should able to know, okay, these are the outcomes which he's going to achieve after completing the program. He must understand those outcomes. And lastly, he must be able to see as to, he must be able to do. Then only those outcomes will be seen and visible and observed and measured also. And we as institution has to provide that learning activities, that learning environment to students to reach to that particular outcome. Now, whether he has reached that outcome or not, for that, you've got to have a proper assessment criteria, which I think in the day before yesterday lectures, you had learnings from Biasha ma'am as to what she was talking about, how the rubrics are made, how the outcomes are measured, and how the outcomes are attained. So those criteria have to be formulated and have to be measured with what are the outcomes we have set at the beginning. Lastly, once you know as to these are outcomes you have achieved, whether we can make any improvement in that or not is what is required. So that's why this outcome-based education is a continuous process of improvement and learning. Let me first tell you as to what are the basically terminologies which are involved in outcome-based education. You must have heard they say something of PO, that is the program. So program is nothing like you have BArch program, you have BFA program, BSc program, or MArch program. So these programs have got certain courses, like you've got design course or construction course, history of architecture course. So these courses are nothing. These courses are basically the subjects which were there. And the philosophy of this outcome-based education is basically what is viewed on the bottom right side of the slide. That means these outcomes are based on the mission. I'll be talking about that in the next slide. Is based on the mission of the university, of the school, and what are the program education objectives, then the program learning outcomes, and the course learning outcomes. So these are the learning outcomes which you make it right at the beginning, and you plan accordingly. And to get this thing, you do it by aligning your course syllabus, aligning your teaching methodology, pedagogy in such a way that you're able to assess and measure those outcomes. Then once assessment happen, you check whether you have been able to attain. Like, okay, in the beginning of the thing, I've thought in my course, 60% of my student should be able to pass. So that is the course outcome which I've taken right in the beginning. And during the end, I'll see the result and I'll measure it, and then I see whether I'm able to achieve that or not is what is going to be there. And then slowly, I'll raise the bar. So this is how continuously improvement, you're measuring it, you're first setting the goal, you are measuring it, and then you're improving it, and then you're continuously making changes in it. That means this is a continuous process which is happening in outcome-based education. Okay. Now, if you see, like I've told in the previous slide, the university has got its vision and mission. Then it's got your program education objectives. These program education objectives, you're not going to measure it right now because this is going to happen after few years. I've started the course now. 5 years down the line, one of my first batch people will go into the field. And then after 2-3 years, I'll take a feedback from alumni, feedback from the industry as to how my students are performing. So this is how, then I will measure those program education objectives, which I measure it once they have gone into the field. So that is the graduate attributes which a person should have, is what I spell out right in the beginning. And then I see whether I'm able to achieve that thing or not by doing surveys from industry, from alumni, and from employer surveys, and result of that is measured and seen and evaluated. Next is your program outcome, which you get sent immediately after he has completed the program. That you can know by the result. The direct method is knowing by the result. Indirect method is what you get it from your survey, which you do for the students who are just passing out, whether they have attained those things or not. And the next one is under a different programs, you have got different courses. So they are known as CLOs. So, or the course outcomes. So these course outcomes you come to know on completion of that particular subject or course, and on evaluating, that is, you've made a formative assessment, you've made your summative assessment, and you've made those direct assessments you have done. Then indirect assessment is you're continuously doing service. Like NAC also, NAC is a national, uh, your your NAC is basically nothing but a National Assessment Accreditation Council. So they spell out that on completion of the course, you have to find out whether you've achieved those course outcomes or not. So those are the things which you have to measure. Next, I'll just talk about as to what we're going to the 21st century. This is what is my thought process, which I've spelled out right in front of you. That is, 21st century will not be what you can read and write, but it is for only those who cannot learn, unlearn, and relearn. That means every time, because of the changes which is happening in technology, we have to basically unlearn and relearn. So that is what my students and all our my fellow colleagues who are practicing and my fellow colleagues who are teaching should do for themselves. So that means what I mean to say is, like, I believe in the philosophy that learning happens first by teaching, what I'm doing right now. Second, I also learn from my peer, and I also learn from basically I do self-learning. And last is lifelong learning, which we're doing right now. We are learning something and learning new things. Now we're learning what is outcome-based education. We're also learning as to what is the new technology has given us. So what I see after 40 years, after 2040, there the pillar which is going to be there will be more dominated towards intelligence. That means I'll be talking about that in my latest slide, but I've just spelled out these three pillars which is going to be there. That is what is going to be, what is happening is intelligence, that is AI, another thing is taking over. Next is the flexibility which is happening. So flexibility in user demand, requirement, and also flexibility, which is also happening because of the climate change and other things. So their sustainability factor also comes into play. So to have these pillar move, we have these drivers, which is driving us from behind. That is changing, which is happening in technology, changing every day, happening in the new techniques which are coming in and making our buildings, and changes which is also happening in our materials. Now we are no longer making buildings with, like we started with stone, then we came up with wood, then we have brick, then the concrete, then the steel. Now new materials, self-healing materials are coming in. So we are making titaniums, sheets and other things. So new material and new nano materials are also coming in. Self-healing materials are coming in. So this is what is the drivers are these technology, techniques, and materials. They are the ones who are changing. And to have this change, we've got this Pentagon. I've just spelled out and made those 5 things. That is, they're changing, which is happening in modular design, parametric design, generative design, computer-aided design. Then the automation design, vehicles and equipment is also happening. Now, at the end of the day, if you see on the right side is the graduate attributes. So this is what I have got it from actually NAC or NAB. So National Accreditation Board is what they have just spelled out. So they are actually more towards, if you see on the engineering side. So I'll be just talking about it later also, that we as an architect association or our COA should have to take up this lead and make them like the graduate attribute, which is there for engineer is not going to be there for what is going to be for an architect. There has to be certain changes. But the 3 things which is there is the knowledge and the skill set which is gaining, and the attitude which he is getting after completion of the course is what is spelled out here. That is, first is the knowledge, is a disciplinary knowledge, is the knowledge which you have for your architectural course is what has to be defined. Skill set, that is the communication skills which I develop, and the critical thinking, whether I'm able to have it or not, and whether I've got this problem solving abilities. So these are the skill set which is required by an architect who's going to be there after passing out in the 21st century. Analytical reasoning, research. Now, more stress is also coming in on the research. Like what I've done is I've gone through, I've done some research and I've come up with some solutions. So these research related activities have to go on, has to be inbuilt in all of us and all our students and all the practicing architects also. Then whatever I'm teaching, like whatever I've taught and whatever, in case this lecture I've taken, whether I'll have to do, whether all these actions are correct or not, or whether I can do it differently. So that reflective thinking thing should also be there in me. So these are the skill set which a future ready architect should know, or whether whatever building I've designed, I could have done it differently if I do it later on. So those are the reflective thinking things, skills should also be borne by a student who is graduating or the practicing architect. Then the information and digital literacy should be there. As on we're changing, we're getting different programs and software, whether I'm abreast with it or not. And the self-directed from self-motivated directed learning, whether I'm able to do it or not. And the attitude, whether my attitude is there to work in a teamwork, whether I have a scientific reasoning, whether I can work in a multicultural environment, or whether I have followed the moral and ethics awareness and reasoning, whether I'm following bylaws properly or not. Like you did, last month only, there were some buildings which were demolished in Gurgaon because they were not constructed in the proper bylaws. So whether as an architect, whether I was involved there or not, is what is the ethical and the moral values which I must have, whether I have got that leadership quality with me for others to lead, and whether I am doing my lifelong learning or not. So these are the skill sets, so these are the graduate attributes which I have to give to my students who are going to pass out after 5 years, is what I am thinking of. For this to happen, I've just taken one example of one of the schools where they've got the vision, which is spelled out right at the left side of the university, then the mission, which is there, then the program education objectives, and the program outcomes. So these program outcomes, remember, what NAC says, they spell out around about 12 program outcomes. Whereas for architects, we can have, I have just clubbed this is what I've taken from one of the architectural schools. So we can club it only to, we can go only up to 8 or so. So this is where our COA has to take a lead. That, what I mean to say is, like what is happening in America and Australia and Canada, they, over and above NAC, they have got NAAB, that is National your Architectural Accreditation Board. So that is, and they spell out their own program outcomes. Like what yesterday, day before yesterday, Vinay sir was saying that in the course curriculum, AICTC, they had developed a certain basically curriculum. So they are the ones who should be more responsible to make our program outcomes suiting to our architectural requirement, and that should be then circulated to all the other institutes to make certain changes and moderation or tweaking it based on their regional connects. Okay. Now, this is another big headache which is there. So this is, I've just made this your metrics, and where I've thought, okay, we have to move from teacher-centric towards, as per the new education policy, we all have to move from the teacher-centric to student. Then we also have to move vertically also from low technology to high technology. That means in student-centric things, if you just get hold of any document of your NEP, so they have given everything to students. That means the choice is given to students for the choice-based credit system. He himself is selecting as to what courses he is going to do. Then he's also collaborating with his team member, like in Bahamas kind of teaching. We always go by learning by doing, and that too learning by doing if you do it in a group. So that means you're collaborating with your other peer members and other team members to do the thing. So I've just these 4 and 6, I've just added this choice, added this, and for that collaboration to happen, you got to have a communication skill. Then you got to have your critical thinking because you're doing something by learning, by doing, and then you got to have certain creativity. And lastly, the corona has all given us caring. You got to have basically compassionate towards your other members also. You got to be caring. So these 6 things happens once you switch from teacher centric to student centric. Now your teacher is no longer at the giving lecture. He is actually he is there with students to help their students take it forward. Like what has happened is he used to give lecture, which is there in the lower bottom quadrant. He used to just give lectures. There used to be certain hands-on activities and finish. Now, if you move towards the right side, now you give the case-based real projects. Start with the real groups so that from internet, from other things, they pick up from the real world those projects and start evaluating and start making problems and start finding solutions to that. So that is what is the case-based project which you get it from real world. For this also, what I recommend is in my teaching, which I do it here, I start prior to midterm, I start with a larger group, give them some projects, then from slowly, because you remember there's something known as teamwork and other things, those skills, you remember those knowledge, skills, and your attitudes. In that, there's something known as leadership quality and teamwork. So that's why you start with the larger group. Then till the time you come to the end of semester, post midterm, you make smaller groups and you use assigning and assessing them. So this is how you can also do it. There's something known as differential instruction, which is required, very much required as per the new education policy. You got to handhold the students who are not, who are slow learners. For that, you have to organize remedial classes, put in extra work. So all this is happening when you're moved from teacher to student centric, but everything is low tech. Now, if you go on the upper top quadrants, there what has happened is a new thing which has come is known as inverted classroom. Inverted classroom is nothing as to what I'm going to teach today. Like whatever lecture I'm going to do today, I should have shared that data with all my students yesterday, one day prior. And in the class, I'm only having discussions and having and solving your problems. So that is what is known as inverted kind of a classroom. Okay, if you move towards the right side, now you start giving, so whatever lectures I'm making, I'm recording those lectures, sharing with students. So basic projects are there, where video lecture recorded notes are there. And now with the new education policy, it has become more personalized. That means the student has got more freedom because everything is available on the net, on the virtual media. I've got my lectures posted there. I've got my assignment posted there. The student at his own leisure time will go there, click on that, click on which all courses he will take it from there and do whatever assessments there he's going to do it and then send it to me, and automatically by the machine it is going to be, because they are all automatically fed, it will be assessed and the result will be given to him. And there are certain other things, if you talk about the high tech, is they're the computer based. Like there are certain softwares we also teach, like I teach structures and other and building construction. So I use this computer based software and gaming sites where the students can go in and it becomes more of an interactive kind of a teaching which takes place. So that is what we are moving. If we are moving towards on top where I've written it, just like just in time teaching. We are moving to an environment where students, just from the click of the button, we are moving towards everything towards a virtual reality and the virtual mode, where all lectures, everything is posted on the websites. And from there, students are just picking up whatever assessments they want, whatever lectures they want to go, in whichever order they want to go, is all freedom is given to the student. This all can happen if we move from teacher-centric to student-centric, and then we move from low technology to high technology. With this, in this viewfold, I'll just talking about what is the total change which is happening. The total change which is happening is because of the new education policy. The education transformation is taking place. Now he can just pick any teacher from any school from anywhere. So the flexibility and timing is there for students to pick up from anywhere. He can, whatever his needs and interest, he can add those. Like in the new education policy, our like COA still have to react to this, that there is something known as exit policies. There's something known as your academic bank of credit. That means whatever courses I'm going to do, I'm going to collecting those credits with me, and those credits will be available and there in the self deposit. And then I know, okay, if I do. So what actually NAPE is done it for a 4 year. They've just spell out, okay, if you do first year, that means you will get a certification for that course. If you do 2 years, then you get a diploma for that particular course. If you do 3 years, you get a pass, bachelor's pass for that course. If you do it for 4 years, you get bachelor's with honors. That means more research oriented thing is there. And slowly then you move on to your PG and other things. But COA has to react. For us, it cannot be followed blindly because ours is a 5 year thing. So we have to model it and think on those things. So those windows and those discussions of the exit policies and credits, another framework has to be done. So besides that, what is there is what is happening right now. That is the need of ours is of a blended learning. Blended learning is nothing as to now we are having this online chat. Now this whole thing will be recorded and then it will be shared with all of you in case you want to have it. So that means this is what is the blended learning and the blended teaching which is happening nowadays. And similarly, there's also certain things which is happening too in the reforms, which is taking place in examination. That means we are moving more towards an open book kind of a thing. Group exams are there, oral exams are there, online on-demand examination is taking place. Online test, like I'm also there a member of the National Education Policy cell of my institute. So there we have to formulate the framework as to how examinations are going to take place, how the exit policy is going to happen for all the programs which we are going. So like that, where we have seen is now we are moving more towards creativity projects. We are all also assessing students online. We are also assessing students on portfolio. Like what has happened now is because of this COVID kind of a situation, all of us have suddenly moved from face-to-face to online. That means we are now constantly learning. We started, so I told you that learn, relearn, and unlearn and relearn. So now we have relearned as to how to take classes and how to take lecture on the Google Meet, on Zoom platform, and how to now, in case I have to write something here, how I, with a Jamboard and other kind of a thing, I'm going to convey this to my students. Like it happens, sometimes it becomes so boring as to you're just speaking directly to the screen and you don't have any interaction coming in or you don't have any question, other thing coming in. So for that kind of intuitive kind of a thing, you got to develop like those pop-ups which is going to come up and then the answers and you are just answering your students accordingly. So this is how we all are learning and relearning. Now, the three pillars, which I've already told right in the beginning, that architecture education is a technology discipline thing where you have it for the process of design and production. Then we cannot be insulated from this. We have to include this in our curriculum. That is, we have to integrate. How many of us have integrated our computer application, latest AI in our course curriculum? How many of us have done AR in our course curriculum? How many of us has done the BIM modeling and other things in the course curriculum, which I'll be just talking about later on. So this is what I mean to say is a rapid development is making us, forcing us to make these changes in our curriculum so that our teachers are aware of these and so that our students are also aware of this and they become good in those skill sets. Now, like what I talked about, intelligence, sustainability, and flexibility, that means what I meant was basically that there is a continuous process of innovation which is taking place. So this innovation is happening because of the changes in population which is happening. Rapid growth of population is happening and everyday user demand is changing. That means something of the incremental kind of housing design which is done. So every time the things are changing. Like previously we used to design open office. Now with the new COVID kind of a thing situation coming in, now how do you design hospital for a COVID kind of a situation where you have designed earlier with a lower volume? Now you want more spaces and more isolated spaces. So whether my design is more flexible or not, So that is what is the next step which is there. So this flexibility can only happen if I'll tell you later on whether we have modular kind of a construction which is done to us or not, whether we've got prefabricated kind of construction which is incorporated in our design or not, is what is to be seen. That means now automation is also happening continuously. That means we are doing concurrent designing. Previously, it used to be sequentially. I made something, I gave it to structural engineer, he does something, then I gave it to MEP consultant, he does something. But now that is no longer the case. Now everything is on a BIM model, and each one of us are putting in our parameters, and all work is going concurrently, and one model which is there is getting repeatedly updated. So that means intelligence, whether it is AI or generative design, parametric design, those kind of things are there. Flexibility, whether you have your prefabricated or you have your modular kind of a system which is done there or not, whether adaptive thing which is incorporated in there is not done. And lastly is your sustainability, where whether we have thought about the climate change which is happening, whether nowadays there's another buzzword which is going on, which is known as circular economy. Previously, it used to be all linear economy. Now, circular economy, there's no wastage. Whatever is the wastage which is coming in, re-put in the system and reuse. Like I'll tell you, there's one architect who's working down south, is a young person who's just making his walls and buildings with the construction demolition waste. So those walls he's making with those kind of a thing. So this is how whatever in Europe, they've just gone one step ahead. They've got this material bank which is available and which is known to all of them, all the architects. They can pick up any item from there and can use it. That means it is basically reuse, recycling the thing, and there is no wastage which is happening in that economy and the material. So all this thing is happening because of the your latest, which is happening in technology, because of the techniques and because of the material. Now, if you move to another, I talked about this pentagon of change. After okay, happening in intelligence, flexibility, and sustainability, and because of the technology, these 5 things happen. These 5 things I have just spelled out. If you see in the right bottom right corner, where a box which has got this arrow also with it, that means our future, all my architectural institutes are going to have something in 2D and 3D representation. They must have something, and this is what I've got it from the research, that they must also have their BIM kind, that is building information modeling system. Then they must also teach parametric design. Then GIS, geographical information system, should be there. Then the digital fabrication, 3D printing, another thing which is happening, is also should be incorporated. Then the simulation in your designs and all should also be there. Then the environmental technology and building technology is rapidly changing. Like you have got slip form shuttering, you've got Mayon shuttering, you've got your other environmental things, your open studio, where everywhere you are just improving the technology related to environment. Whether you have gray water, you have black water, and whether you're recycling your material or not, whether the thermal comforts are there or not, those kinds of things are also have to be incorporated. And lastly, we must also know something about programming, coding, and scripting, and that is what is on the look of it. It looks very difficult, but actually, we as an architect people has provided us with solutions, which I'll be telling you in our next. So all this 8 to 9 feature, I've just clubbed it into these 5 things. That is a modular design, your parametric design. Then you've got autonomous design vehicles and equipments, where drones and other things also comes into play. Then you've got generative design. And the first one is basically computer-aided design. So with these are the 5 pentagon of change, in which all this 8 to 9 or 10 things will be incorporated. First, I'll just talk about the modular design. So in the modular design, what is basically there is a changing, which is rapid change, which is happening in technology. So rapid change is happening in precast construction and pre-stress construction or prefab construction. I don't know how many of you are aware that there is something known as GHTPC, that is Global Housing Technological Project Challenge, which is there. If I just zoom it out, एक second, sorry, it's gone to next slide. It's gone to next slide. Shit. Okay. Sorry, in this only, if I zoom this, okay. Okay, if you see it there, that means how many of you are aware that your basically Hindustan Prefabricated Limited, the prefabricated limited, they have gone up with this. That is, the Ministry of Urban Affairs has given up these 6 lighthouse projects, which is being mass construction, which is done with the latest technology, that is prefabricated sandwich panel systems, monolithic concrete construction using tunnel framework, precast concrete construction systems, and precast construction system with 3D volumetric, so light gauge systems, or PVC stained your system. So these are, and the locations is also spelled it. You can just Google it and you just come to know. So whether we as teachers are teaching these latest technology to our students at the correct time, work and time framework. So this, let me tell you, in our school at Sushant School of Art and Architecture, we had actually this I've also picked up from my 7th semester. In my 7th semester, we taught our students with these kinds of technology. That means for them to be abreast as to what is happening latestly, which is happening in precast and prefab construction. Moreover, people have moved beyond your pre-stress and precast. They have now, if you go to basically China, if you see something happening in China and something happening in America, there they've gone to PPVC. That is your fabricated, predefined volumetric construction is what is a new term, a new word which is coming in, where all your model, everything is all pre-designed, and you're just keeping it and placing it there. Just Google your broad company, you'll come to know, like it was also there in our your mobile and web, that they have constructed their building, your 10-story building in 9 days or 4 days. Like in Chandigarh also, they constructed something in 10 to 15 days. So this is all is the doing of PBVC. So that is what the technology which we as architects should also know, and we should also teach the same thing to our students. Another thing is, this is also, if that is a technology which we are going to use, it has effect on our design thinking also. That means what units I'm designing has to have effects, has to take that thing also into our consideration. That is, there should be, my unit which I'm designing should be flexible enough, should be able to, it's a kind of incremental kind of a thing which is happening. Like one of my thesis students, she had taken up the project of making residential buildings, which has got this flexibility to expand to 2 units more. So this is what the thinking which has started coming in students right in the beginning. In case we include that in our curriculum, then only they'll be able to learn it. Then remember what the fuck Mr. Fuller had talked about mobility. That is, he designed a house, tensegrity house, which could be placed in one place and can be really relocated at those places. So this is, we're just forgotten those kinds of a concept. We're not teaching that to our students. So therefore, in design thinking, while I'm designing, I must know what is the flexibility, what is the mobility, and what is the dynamically, how it is changing, your house space is changing and contracting. Like, I don't know how many of you are aware that in Qatar, for this FIFA World Cup, they've made up a stadium which is built up, which after completion of the project, all those, it is made up of those containers. And after the work which is done, it will be taken to another place and to a new location, and new stadium will be built up. So that is where dynamic thing which is happening. Then you're also transforming the same space into different user things is what should be taught to students, so that they enhance their design thinking. Next is, you come from this same in the modular kind of a chain, technology you've adopted, you've done your design thinking, then the printing or the outcome which is going to come up should also come out from there. So this is what somewhere is happening in 3D printing. That means you minimize wastage, there's circular economy, and there's a material bank which is happening. And all this construction thing and all is happening through robotic and automation. I'll be talking about this in 3D printing kind of thing and later on. And there I'll be telling you about in more detail as to what all the new innovations which has happened and which should also be taught to our students in our institutions also. Next, if I go from there is next after modular is your computer aided design. It is actually nothing is a computer aided. It started with computer aided basically drafting or drawing. That is a CAD software. It is only after your Frank Gehry, he made his buildings along with the CATIA software, which was used for the military purpose, where all the parameters were given to the software and then the building was output was taken on. So from 2D, we are moving now towards a BIM kind of a concept where BIM is in the 3D model. I'll be talking about that also later. But for this, a lot of work which has been done in India is also done by Space Chen. He is the one who supplied us our first AutoCADs and other things to us. Even the Rivet and BIM has all been provided by him only. So he has got his company. So we have we all as an institution should also tap these people who are there available in industry and should teach our students also. So his company that is Apriot is also doing a lot of work in this. Then after BIM modeling, previously we used to make sketches, we used to make basically your perspective drawings and other things. Now those perspective drawing and other things have gone because you've got your BIM model. Through BIM model, you can do your VR, virtual reality, your augmented reality and mixed reality. So this is what also I'm going to talk about in later on once I go back, go into details as to what is VR, what is AR, and what is MR. And for this, a lot of good work which is also done by Trezi. That is a company which is held by Gautam Tiwari. And one of our alumni are also there. Vidit Goyal is also helping. They take classes, they take the courses, they've got modular courses who teach us as to what is VR, what is AR, and what is MR. All this is happening because of the changes which is happening in our cloud computing. Now, I'm no longer confined to this PC and my laptop. All my computation and calculation is all done at a cloud because I'm working on that software which is placed at the cloud computing and they're using that power. So that means we are at 1/1,000,000th of a second, we are processing so many iteration and so many iteration and options have been evaluated. So these are the things, these are the improvements which has happened in computer-aided design. That means it's from 2D, 3D, VR, and AR. Now I'll take one step ahead is what is known as your generative design. This is another further one step ahead. Previously, it used to be basically generative design. You just feed in with big data. A lot of data is available, a lot of images which is available to us, and that images have to be put in a particular program. So you got to have basically in generative design. I'll be talking about that also in later, but just I wanted to introduce that in the generative, those 8-10 things I've just formulated in this one of the side of the Pentagon, where I've put in big data, software, AI, ML, and DL. And this is also freely available in case you are more interested in learning that language. You have this Google Colab, which is available freely, and you can do programming in this also. That means previously, if you see on the right side where my pointer is, previously I used to make a design of a chair, which is only, you get it only one option. Whereas the new school of thought is because of the generation, because of generative design, and because of the parameters which I fixed in, I can change those figures accordingly, and my design and my options have increased. Okay, so I'll be just talking about that also. So after this generative is basically you got this automation design vehicle equipment. So there I've clubbed in everything related to scanning and everything related to whatever. See, modular design, you're doing something, designing, you're doing something. Computer design is helping you make up those 3D models and other things. Generative design is giving you basically options. Basically the options as to from where you got to go and select it and do it. And now this automation and autonomous design vehicles and equipment is basically documentation which work which you are doing site work which you're doing, that you can also do it by drone, or you can also do it by self-driven loaders, variables, the sensors. Now we're moving to big cities. You talk about smart cities. Smart cities are nothing. There you have got the sensors and chips which is placed in each of the elements which I want to measure. Like in a building, in case I put my chips and sensors, this once I was doing my MTech in IIT Delhi, that is the time in 90s, they was just talking about that sensors is going to be put up placed in the building while construction. And then those sensors will give us basically the feedback as to how the performance of that particular material is happening, how the performance of that material is happening, and then that will be evaluated. And now that is the reality. That is, we are also putting in case I'm going for a construction, there you got this NFC, that is a near field communication. That means your chipset is put there. And if I'm as a worker who's working, and so the safety measure is there in my helmet is also that chip. Once I go near a place where there is a fall, so immediately the signal is given to me through my helmet that, okay, there's a danger ahead. So this is how, whether in construction, I'm using this, or whether in my buildings, I'm putting this sensor, which are further evaluated in BIM. Once I'm doing that 6D, I'll be just talking about what is 6D, which is there in BIM 6 BIM, where I'll be doing analysis basically of as to what is happening towards building, how it is optimized because of the sun and energy things. And another thing, to measure all these things, we are doing it by drone, like by your documentation, everything is done by drone. And on drone, what is fitted is this LiDAR. LiDAR is another, it is actually a acronym for basically light detection and ranging. It is a kind of a software or the laser scanning or 3D scanning. So this also, we have taught one of our elective, one of our teacher had taught this LiDAR, where this is nothing new. It's also available in my iPhone. iPhone i13 has got this LiDAR thing inbuilt in it. That means you can scan the photo. You can scan the photo and the depth and all, everything will come up in it. Now I'll just give you, I don't know whether it's going to run or not. I'll just show you this. It's running or not. Is it being heard?
No, sir.
No, sir, not
Are
yet.
you able to see this? But it's seen on my screen. Can you see something?
No, sir.
Your presentation is up on the screen, sir.
Okay, this is not coming. Okay, how? Oh, shit. Okay. So this screen is not, because I pressed up this link, and that link should be, now my screen is shared whole, huh?
If the screen is shared, then it should
Sir,
show
your
up,
presentation
sir.
is there.
Yeah. See, our screen is shared, so this is coming on my screen only, na?
Sir, you might need to share the screen where that link is being opened.
Okay,
Maybe
so I'll have to redo this, eh?
Yes, correct, sir.
Ek second. I'll have to stop sharing and then share that link wala thing, na? Okay,
Right,
I'll do
sir.
that. Okay, so this is what I say is lifelong learning. You learn also while doing something. Let's see if it happens. That image thing is not coming here. Okay, that file is not coming. Video file, optimize video clip, share sound. Okay. Now my file should come basically. Now it is shared.
We can see the pop-up. Namit, sir?
No, can you hear it now?
No, we can't hear you, sir. We can't.
No, we can't, sir.
Even the screen is not seen. Okay, ठीक है. Okay.
Sir, is it a software out of your PPT or is some kind of a presentation like other presentation?
No, it is. I've linked one video with this, so
Okay.
that video is being shown. So that is not coming. Okay, no worries. Okay,
Okay, sir.
don't worry. It is actually nothing. I'll just tell you what it was. Basically, it is a Froster and this thing. They had made a company where what has happened is they've got this software which is placed right at the top of the dog, and then he goes around the places and then scan. Like what is happening now, this kind of a technology is being very well effectively being used in basically rehabilitation or conservation work. So there, and the same thing is also happening in my self-driven cars or your self-driven loaders. On top of it, you got the scanning thing. It goes, the lights are emitted, lights are sent there, it comes back, and it automatically make a 3D model. So once the 3D model is made, so then that 3D model is of the 3D model of site is available to you. Then you can import the same 3D model into your BIM kind of a software and in your BIM environment, and then you can start working on it. So that what I mean to say is, instead of previously we used to do those micro sessions, we used to do those surveying and other things. Now all those things have been now done with a click of button with this leader kind of a technology, which is now available to all of us. Okay. I'll go back to next slide. Is it moving? Next slide.
No, sir.
It's frozen there.
Yes, sir.
Wait a second. I'll just know it. Now it's gone.
Now we can see
Is
the
it?
Pentagon 5.
Pentagon 5. Okay. Now we'll come to, after you've seen what is there in your autonomous design vehicles and equipments. This last one is your parametric design. So parametric design, what has happened is it is basically that you've moved towards from 2D to 3D, and the 3D which is available is basically your passive design, where your passive parameters is allotted. That means in Rivet, in all my elements, that means whatever my wall, your material, length, breadth, everything is assigned. So that is what is happening in my AutoCAD kind of environment. And same thing is also happening in the Rhino kind of environment, which is a competitor for that. So they are also making those basically passive kind of parametric modeling and parametric work has been done. Now to this parametric work, if I start assigning, something is known as start assigning my algorithm in it. That means I start doing the programming with it. Then you get that software, and the software which is available freely with the Rhino works as a Grasshopper, and with the Rivet you got the Dynamo Studio. And the most people who are doing work in this is also one of our alumni, that is RAT Lab. That is Research, Architectural and Technology Lab work, which is done by Shishant Verma. So Shishant is the one who's taken up lead in this, and he's teaching students all over the country in this RAT Lab also. They've also made buildings, and they've also made structures based on basically using this algorithm. And afterwards, another people who is doing some research work in Europe, another thing is BRG, that is the Block Research Group. They, in collaboration with Zahidi, they have also made certain codes. So they've gone one step ahead. That means after you are doing programming, now they've gone into the generative kind of a design. So in there, you've got this object which is known as Flinch 3D and Refinery. Yes?
I'm sorry, there is the clarity in the slides. That is what everybody is writing. So
clarity
I
is
think
not
you
coming?
have to, yes.
Okay, I'll reshare.
Earlier,
okay,
the slides were very, very sharp.
Yes, sir.
Okay, okay. No worries. I'll do it. I'll share it again.
I thought I am facing some internet issues. Then I read the comments.
Sorry. Now, can you see the slide?
Sir, they are blurred,
It's not
sir.
clear, sir.
Blur? Okay, why it is happening blur? Wait a second. Stop sharing.
Somehow I'm pixelated. I'm sorry, ma'am. I'm Meenal Yaram Shetty from Mumbai. I'm not seeing anything on my slide.
So,
Okay.
Meenal, I think you need to restart, but we are able to see the pixelated slides at least.
Okay, so I
the
go out of the
problem is-
meeting and join
yes,
again?
and then join back in. Yes.
Okay.
Just try doing that.
Okay, thank you. I'll just do
Wait a
that.
second. How to
Sure.
now? Abhi screen share. Okay, I'll share my screen. Now, is this screen shared? Now, can you see something?
We
It's
can
still
see it, sir, but the
pixelated.
pixels are
Yes.
not good.
Pixel are not good. Okay.
Sir, by any chance, are there any other softwares running in the background? Because this
No,
Zoom
nothing.
consumes a lot of data.
Nothing. Actually, basically what is there is my internet connection is basically going. Now, can you see something? Is it clear now or still?
It's still the same. So, sir, would you like to rejoin? एक बार करके बंद करके फिर से?
I'll rejoin.
Okay, okay, sir. We'll try doing that then.
I'll do that. I'll stop sharing and I'll.
So you can try it, make it a PDF if it is convenient to you.
PDF तो okay, because time लगेगा भी बनाने में.
Okay, okay.
Virendra-
Please,
नहीं
please,
नहीं, that's
share.
okay. No need of the PDF. वो sir एक बार वो join करके.
I'll rejoin. I'll just go back and
हाँ.
then come back.
I think,
Okay,
Virendra sir, you can do one thing. Just check with your PowerPoint presentation whether you have put the settings at the lower resolution, because earlier presentation was all good. When you had zoomed in, I think you have, by any chance,
Default.
you have
Okay.
you have put the images for the lower resolution, and that's why when you're actually displaying, they are getting pixelated. So you can
Okay.
cross check that.
एक second. Let me first rejoin first and then do the.
You're on mute, sir. You are on mute.
Okay. एक second. Okay, I'll have to. Before coming to this, I have to open that slide.
Technology challenge भी करती है, sir.
हाँ, टेक्नोलॉजी चैलेंज तो पक्का करती है. यही तो मैं, that is what I'm saying ना. We all have to learn from here only.
जी.
And automatically we'll have to learn something. Because हम Zoom पे ज़्यादा, we all work basically Google Meet जो freely available software है उसी में काम कर रहे हैं. Zoom में तो okay. Let's see what comes now. Hopefully it should come.
And one of our participants suggested, if you want to share the presentation, we can you can share with Navneet, and we can.
हाँ, we can do that all. वो मेरे को
We
पहले
can do
करना
that.
चाहिए था. We can
हाँ,
पहले करना चाहिए था. अभी
कोई
let's see. अभी हो जाएगा.
No problem.
अभी हो जाएगा.
जी, क्योंकि इसके पहले तो हो ही रहा था अच्छे से.
वो actually she is right. मैंने कहीं पे वो उसको जब वो कहते हैं zoom करा था तो maybe उसके कारण ही हो गया. Now can you see it?
Oh yes,
Yes, sir,
perfect.
perfectly
Perfect.
fine.
Sorry. So this is how, that means what I mean to say is learning happens like this. Also.
Oh, thank you,
ये सब slides
Arpita.
इसमें anything you want,
You're
I'll
welcome.
do it. I'll repeat wherever you want. वहाँ से start कर सकते हो. ये सब you have seen.
हाँ, ये सब
It's all you
सब
have
कुछ
seen.
perfect था. वो लाइडर के वहाँ से yes. Go to that
Okay.
LiDAR
वो LiDAR
slide.
से once I started getting into that LiDAR से तो उस समय हुआ. Okay. Is yahan tak it is okay? NFC tak, then Rhino, Grasshopper, Dynamo, parametric is it now visible properly?
Yes,
Yes.
sir.
Okay.
Yes, sir. Yes, sir.
Okay.
I think you can
Okay. Now
resume
I'll
with this slide only. Yeah.
Okay, you want me to go back? Okay. That means what I mean, what I was talking about was basically it is the passive measures which has happened in the 3D modeling. That is the parametric. Basically, it also there's something known as your computational design. Then there's something known as generative design. So we'll be just talking about it later. Right now, you've got this Rhino and Rivet is a passive where the parameters are assigned to a particular entity or a model. Then to that model also, Rhino and Grasshopper allocate basically the algorithm to it. And for Rivet, Dynamo Studio does the same job. Then there's another something known as Flinch 3D and Refinery. Now, Flinch 3D is also in the developmental stage, which is done by the BRG, that is the Block Research Group. They are the one who, in collaboration with ZA Codes, have developed a codes. Basically, they've made up a actually with the 3D print, they've also collaborated, they've also made integrated 3D printing into it, and they've made a bridge which is made up of limestones, but with no joints, with no mortar. So that is, they could do it only because of this, basically the generative design and this Grasshopper and the parametric kind of a thing. And there's something known as Karamba software where all your structural elements and structural forces and structural calculations are all put in, and that can also be dovetailed into this, and then we get a complete solution for whatever buildings I'm making. So that means I'll go to parametric. So parametric basically is nothing, that is by playing with the particular parameter, that is by adding something to it, by adding basically the data into it. So you get different shapes and forms. That was not possible before. So within seconds, because of this, your programming language, which you have done it, you can have different kind of options or outputs which can come out of it. Like for an example, in case I've made a tower in a city which is mostly cloudy, and I've set my parameters which judges the amount of daylight is going to happen that particular day. So within seconds, with these tools, we will be able to simulate a situation for that particular day and that particular time, and you can come to know as how much is the energy saving which is going to happen and how much is the daylight which is going to happen to that particular place. So these softwares and these tools also have to be incorporated in our your school curriculum, as well as has to be taught to all in the FDP programs to all other budding architects or practicing architects. That means what I was just talking about was these three things. That is, AutoCAD is nothing, but it's a traditionally design. It is a computer, it's a drafting tool only. It does not have any parameters attached to it. Once to this drafting tool, you make a 3D model, you start attaching the parametric models. That is, you start attaching the elements to it. So then that becomes a parametric model, a design solution which is available to us. And through that design solution, if you start making, after adding parameters, you start adding algorithm to it, then you got different computation is done to that model, and you get different solutions to it. Okay, and then in the last, which is still in your development stage, is where your design automation is done, optimization is done, and everything is taken over by computer, and it gives you a direct design to it. Okay, that what I mean to say is this generative design, which is that third stage of computing modeling, is nothing. It is a substrate of the later one. That is, you have CAD, you have BIM, you have computation design, and through it, you've got those machine learning. Machine learning is also nothing, which I want to tell you later on. Is machine learning is basically a process where the machine learns from the past experience. Like if I put that software in my laptop only, that software which is known as log, which is freely available. So whatever actions I do, it records. Like you must be astonished as to how come on your mobile, once you're making any purchases or something, suppose I've bought your vegetables or something, or fruits from grocery market, and suddenly I start getting same kind of messages in my mobile about the same kind of routes and this thing. So this is how it is, your machine is learning and just telling to others and sharing the same data with others, and you're able to get those messages. Same thing happens on a Facebook. Once I like one kind of a page, I start getting messages from there. So this is how my machine or my laptop or my mobile learns, and the machine learning happens. Similarly, if I design a particular building in a certain way, two-bedroom house in a certain way, I get a lot of all things are being recorded, and suddenly I get, if I click on it and want to find a different two-bedroom house, so I'll get different options available through it. This can only happen once you let your machine learn through the experiences which you are going to do to your basically the machine. Okay, so same thing how they have done it. So in the machine learning, there only you get those generative design. And if you see on the right side, I just got one complete no, abhi isko main zoom karunga to phir wo is the same problem will happen. Okay, if you see on the right side, same thing, you got your one basically tower. In that tower, you start putting your structural element, then you start putting your support conditions, then you start putting your nodes conditions, and then immediately the machine will give you, or this software or this algorithm will give you the optimized solution which can be done for that particular tower. So this is what we all have to learn. This is what we all have to teach our youngsters. Same way, now I'll move to another. From parametric, now we've got this AI, ML, and DL. Now, AI, ML, and DL is nothing. AI is basically, it is artificial intelligence. It is basically ability, it is a bigger set. That is ability of technology to make decisions independent of human inputs. Okay, like this is where what is happening, how self-driven cars have been done. So this is also happening because of AI. So I'll tell you how it is done. Before you move to self-driven car, the same car has to go through machine learning. That is machine learning. That means ability of technology to learn from past experience. That means that same car, you got to have pictures on the path which the car is taking. Those picture and photographs are all stored in that particular machine. And also the whatever activities you're doing, if you're turning the car left or right, so those actions are also recorded in a particular machine. Now that thing is now put on that, remember I told you the later software kind of a thing, which is put on top, and that scans and just make a particularly 3D model, and then the guide basically the car to move towards left or right. So this is how it happens, machine learning. Last one, from this machine learning, now in this machine learning also how it stores. It basically stores data in three ways: supervised, unsupervised, and reinforced. Supervised data is that data which is in a labeled form. Labeled form means it has got weight, height, everything. Like suppose I'm doing a survey for a particular community. There I've got, okay, what is the height, size? So those labeled data is there. So that labeled data is put up, is known as supervised data. Another is unsupervised data, when there is no labeling. So then it forms based on the similarity of the data, the machine forms the basically clusters and groups, and then take particular decisions on it. Last one is reinforced data, is a jumbling up of everything. So based on that, at what time phrase and at what time I have done it. So this is how they make that reinforced data. So this three kind of data which is available, that is further processed by the algorithm, and then you go into deep learning. So DL is nothing like a deep learning. Deep learning is nothing how my brain works. So that is what is the technology in which they have basically linked everything to how my brain works. They've done research on that. So using multi-layer neural network algorithms are made. Okay, so that is ANN. ANN is artificial neural network. CV, and which deals only with basically the numbers. Now CNN is another processing which happens, which deals only with images. And RNN is the one which is an algorithm which does everything related to time and other things. So this is how they have formulated, and this is how the data is done. Like here only, next image down below is lob only, where I've just given that image, where through lob also your machine learns. And next is the freely available software which is on Google, that works on Python programming. So there also you can import data but more for all of us, as this is what is more for engineering, whereas in case you want, you can also do it with what I've told you before, that is 3D Fringe and other software which can be used and can be taught to our students. And this is how, with the 3 parameters, through Glob, Google Colab, you got outputs, like you're given outputs. Thousands of pictures have been scanned and put in the data bank, and through that data bank, the parameters which I've set for the material, for the user, and for the time, through that it designs give me options of the building. Okay, so this is how what happens in AI, ML, and DL. For this also I had a video, but unfortunately it will not work. Like this is where, let's see if this works. I'll not run the video, but I'll just ye link shayad run kare. Like in this case, what is there is basically like what I was saying now, thousands of images have been stored for 2-bedroom houses and 1-bedroom house. So this is also freely available, and people are working on doing research on this. And this is where it comes to next, that is House GAN. House GAN is nothing but the generative adversarial layout refinement network, which is being formulated by making use. It sets the boundary condition, it sets the metric which I gave it, the approach. Okay, what is the interrelationship between the 2 bedrooms, and then it also sets the basically the room sizes based on the parameters which I give, and then it gives me the options. Let's see if this one runs. I'll just do this. Can you see the screen, or is it the same one?
It's the same one, sir.
Okay, then I'll stop. I'll no longer experiment with this. I should have done it. Now can you see the same one जो मेरा पुराना था? Can you see the same screen?
Yes, sir. Yes.
Okay, just note down this.
Okay.
इसको click कर लो, image कर लो. So this you can just go down and do
Yes, sir.
experiments with
Yes,
this.
sir.
So that could be, and then you will know how, what I said is how you can just experiment with this thing, and your 2-bedroom house and 3-bedroom house can be easily designed if you put in those data there. So those data and images have to be put in, and then only the machine will learn accordingly and will give you solutions. Next is the last one, which is basically your BIM. BIM, mostly people are confused actually. BIM is nothing but it is a process. People say it is a software, वगैरह कुछ नहीं. It's not a software. CAD used to help people to draw. BIM help people to construct. BIM is not CAD. BIM was never meant to be CAD. But CAD is actually a replacement of what we do in pen and paper. Okay, and it's a documentation tool. Whereas BIM is program-driven application in which documentation flows in a derivative of process. The process. What I mean to say is that remember in our AutoCAD, all your drawings are saved in DWG format and can be opened in those kinds of platforms only. Whereas in this also, in case I'm working on BIM, I may be working on AutoCAD or in the Revit mode. My structural engineer may be using Tequila software or something. But whatever 3D model which I'm going to make is going to be in the formation of IFC. IFC, like there I had DWG. So my 3D model in this case will be IFC. IFC is International Foundation Class. So that is the file name which I'm going to have, and that is interchangeable file which can be viewed by any software. And this is how the whole foundation of BIM happens on this. So there are certain dimensions to BIM. Like I have made a model, I made a model in Revit. So that becomes my 3D BIM. So it's a dimension 3D. So 3D BIM, it's only got those parameters available to it. Now, if on the same parameter 3D model, I start putting in time and my construction building in it, it becomes 4D. Then I call that model which is available to me as my 4D model. Okay. In case in the same model, my people who is my surveyor and other things start putting in the cost factors related to it, quantity factor related to it, then that becomes my 5D model. That means the dimensions of BIM is changing from 3D to 4D to 5D. Now, if to same model, if I start putting my energy, if I start embedding, it's nothing, I'll tell you later on in next slide, that is nothing in the 3D model. One is a graphical thing, other is the basically information thing. So those information things which is embedded is of this 4D and 5D and 6D. 6D is that you have started putting in your energy simulation, energy kind of a thing in that model, so that everything related to, if the model is ready, then I say the same model is known as 6D model. And if in the same model, after completion of my building, if I put well, anything related to basically anything related to my services, which will be required by my facility manager later on, is then that becomes like when the lift have to be replaced and have to be serviced, when the painting has to be done, when the other things have to be done, when the firefighting tanks have to be changed, flushed out, and other new changes have to be done. So that model is known as 7D model. So these are the 7 dimensions of model which is available. Now, in the 7 dimensions of model, how it works basically, abhi isko I'll also not zoom in. Otherwise, what happens is basically your BIM model, you're on the same model, which is of IFC, file is shared by building owner, by contractor, by quantitative surveyor, by manufacturer, by fabricator, my engineers, my architects and designers. And so they are all working on the same thing. Now, the level of detail, now BIM spells out the level of detailing. So level of detailing is more there. If I say it is level 100, level 100 means my model which I've got is just a conceptual model. It does not have anything, just the conceptual, just a SketchUp kind of a model which is available. If to that model, if you start putting the approximate geometry to it, like suppose if you see in the picture in the middle, you got the circular square column, and then at 200 level, I put an I-beam. So that means I've started putting geometry to my model, then that model which I get is known as my level 200 model. Now, in case to that level 200 model, if I start putting my constructional details and other kind of a thing, so that construction information and all is all put at that becomes my level 300 model. So level 300 model and then becomes my level 400 model, which is given to my fabricator to do the work. In between, you got level 350, where further fabrication and other things are also, information is also put in. So, and last one is your level 500, which is given to my facility manager. That means information related, everything to my facility manager is all available there. So these are the previous ones were all the dimensions, and these one the level of information. Now level of information or level of detailing, they say level of detailing is in 2 ways: LOI plus LOG equal to LOD. LOI is basically the level of information which is in text form and other thing which is embedded in that model. LOG is a graphical thing which happens, which is your height, weight, width, or break, your wall, your column, your beams. So those are your LOGs, which are there. And totally combined, it becomes a level of detail. So this is how, if it is basically, this BIM is a very useful and powerful process tool which is available, and which I must say we must teach. All architects should know about it, and people have started using this in a bigger projects. And also it saves you time, because of the same model, hundreds of thousands of people are working in it, and you get immediately concurrent and correct information is available to a person who has to make decisions. So this is, and let me tell you, this also we taught, previously we taught fabrication and pre-modeling thing to our 7th semester students. We also introduced them to BIM. So that is how I learned BIM, and I have developed, and we are teaching our students. So this is what you should also do it in your universities and schools. Okay. Next, after BIM is your 3D. Next revolution which has taken place has happened in the 3D printing. Now 3D printing, abhi iske liye bhi I had that video. Okay, if the video is not that, this is the images which I've shown is what is the toilet block which is done somewhere in Chennai, and in between is the 3D printing which is done by L&T at Chennai only. So a lot of work which has happened in Chennai only. IIT Chennai, they have done a lot of work on this. And plus, we also recently have basically our conclave of Mud Future. There we had interacted with architects. It was all done by SSA, and we interacted with people who are there abroad also. So there, in basically it's a ink which is used for those printing is concrete in this case, if you see. Whereas now we have also started using mud also in this, and now even the more basically advancement which is happening now, this printing machine uses only one basically material. Now advancement is also, and research is also going on to use multi materials in this. That means with the same printing ink, you can have different materials which can be used. Like you have RBG, the red, blue and green. Like right now there's only monochrome. Now the 3D printer which is developed right now is only monochrome, only black. That means you have only this concrete, either you have concrete or you have only mud, your straw, or that kind of a thing can happen. So abhi advancement is also going on, taking place in this. So what we have done is, like, we also have got a 3D printer available with us. So there students, they make their model in AutoCAD, in the parametric design, and then or to same parametric design, they make model out of the 3D printing, which is on a plastic or that plastic kind of a material which they use, and then the model is made, and then they can do. So that means we are also using that learning by doing thing which was taught to us by us, kind of a concept which we are also using and which we should also do it. So that is what I mean to say is the lot of advancement which is happening in 3D printing. And another research which is happening, this is how this material, there's a lot of research which is happening on the material itself. That material also, whether this material is basically, you know, getting responsive to environment also. It's changing shape and changing the volumes. So that is what is the research which is happening in the latest techniques which is happening in this material component, and that is being used in 3D printing. And the next technology is what is the favorite one, that is immersive technology. Immersive technology, you have got basically, if you see in this viewfold, this also I had a picture in this, but people are confused as to what is VR, what is AR, and what is real reality. Let me mixed reality. Let me make it very clear to you. Now, if you see what is there in the bottom right is what is VR. VR is everything is virtual. Like you are moving into a virtual frame. You have got the 3D model which you have made it by BIM. Okay. To that, your reality software, AR software, your virtual reality software, you can, with your client, you can go inside that building, putting on those goggles. You can go inside those buildings, your virtual model, and in that virtual model only, you can see what are the textures, materials, or things or spaces which you are getting. So everything which is happening on virtually, like you play on these video games. So that is all virtual thing which is happening. You are only doing everything virtual. Now, what is augmented reality? Now, be very careful in this. Augmented reality is what is basically you got everything in the real world, but it is supplemented by this virtual thing in between. Like what you see is basically, if you see the image which is there, which is the icon on IKEA company and other companies are using in their for their marketing, is what is there is on basically on your iPad or on your iPad or your mobile. If you download that software, and then if you can put this, like in this case, say in case like in top, if you see they are viewing their space, but suddenly the sofa has come into it. Sofa has come in is a virtual model which is placed in the basically your iPad. And through that iPad, you are seeing what is there is the actual picture of that basically space. Okay, so that sofa has come inside virtually. Okay, like what you see down below is the same thing with the iPad. If I got a 3D model, if I got a 2D drawing, and if I just put my iPad there on top of it, if you see in the left, right, if you see, you've seen that image, you've seen that your sketch of a house. And if I put my iPad there, what happens is I have already made my this sketch into 3D model, which is available in my BIM. So that BIM is immediately through the software transferred there, and you can just see the image of basically the whole building there. Or similarly is what happens in the site. If you see in between slide, where some construction workers are standing, through iPad or through the mobile, they are just seeing what is the pipes which are going to come, air conditioning pipes and all, which is already made in a virtual model in BIM, can be seen right there. So this is how the corrections or the changes which can happen. First was everything happening in the virtual reality. You can show it to your client. Second one is happening on site and where you can make all changes. Last one is, so that this is augmented reality. Last one is your mixed reality. Now, mixed reality is where, if you see on the top right side, that is a totally hologram. It works on, basically you've got your Microsoft holograms. Those lenses, you can just put it, those goggles, which are hologram. That means whole virtual model is transferred into my reality. But previous virtual model, I couldn't change any diameters or fixture. Whereas in this case, I can make changes. I can in those parameters. So that's why this is known as mixed reality, where I can play around. If I'm at this place viewing this mobile or building, other person who is also viewing this mobile or building from other side can also see it, and can also, if he makes certain changes there, immediately I on other side will be able to see those changes. That means I am able to make changes in the virtual model which I imported in my real world. Okay, so that is what is known as mixed reality. I wish I could have shown you that image, video clipping, then it would have been more clear. Okay, now I'll go to my last. So this is what is my suggestive modeling, which that model which I want for our architectural schools to basically follow. As per the new education policy, if you see what I have spread out on my top right side is what you've got courses, you've got core courses, they've got 14 to 16 credits, which is available to that. And then in between, you've got your electives. So electives are 8 credits. So it could be your discipline specific elective or generic electives. And then lastly, you've got ability enhancement 4 credits, where you have your ability enhancement compulsory courses, skill enhancement courses. So this is where in these 4 credits, you can start playing around. You can all start having tying up with your peer, alumni and other things, where all your visualization software, parametric softwares, and those things can be taught to your students. Same way, you can have your generic electives, where your AIs, your green buildings, your sustainability, your climatology, your new materials works, or your leader software, or leader robotic drones, other things can be taught there. Then in the design discipline specific, which is related totally to architecture, there you can talk about those subjects, which is like your hotel industry and other things, how development is taken in the office development and office places can also be taught there. So this is how you can just split it up. I've just given one of the model that is from first semester itself. And if you see on the right side, bottom right, see, these are the softwares which should be taught to our students. This is the survey which is done, and which they've come to know, okay, Autodesk, or AutoCAD, 3D, then Revit, SketchUp, Photoshop, Illustrator, GIS, Rhino, Grasshopper, Processing, Microsoft Office, Lumen, InDesign, Blender, Corel, Design Builder. But yes, so many softwares. How much we can start? We can just start either. Now, new education policy also tells us to basically go to this MOOC, mock the massive open source courses, which is online courses, which is available. There the students can enroll it. That is 20% of the credit which is available can be done on mock or SWAM platform. or could also be now COA can take a lead in this and can also develop its own library bank where all this lectures and other things can be placed there and can be viewed by any students whenever they want. So that means from first semester itself, if you see visualization software, SketchUp, Photoshops can go and they can, or from first to fourth, they can be taught. So all this softwares can be taught to them. Then you can also have tie-ups, like I've told you with Tracy, with the Apricot, and with those people, they can also teach you. Then you, from second semester onwards, you can just start on 3D printing, laser printing, machine learning kind of a thing can be taught to them. Then from third semester onwards, you can just start on climatology, green buildings, and GRIA rating, your BRAME rating, and your basically lead ratings. So those things can be told to them. Then from fourth semester,
sorry, sir. Sorry to interrupt. Our other speaker, second speaker is waiting. So we'll
sorry, ma'am. Okay, I was short. So this is, I'll just share my slides with all of you, and then you can just go through it. And this is what I just suggested model, which I've just given. So that means what I mean to say is ki still I'm learning. Like I say, lifelong learning. So this is, I'm still learning. We all are still learning. We are all relearning and unlearning and relearning. So our journey continues. So this is what is the technological advancement which has taken place, and we should all be not insulated from it. We have to embed it, we have to adopt this and use this. Okay, so this is what is my session. And sorry, I have took up time because of the hiccups which happened in between. And in case anybody has got any questions, otherwise I would have gone on and on. Thank you for reminding me.